find, guys, that there's a lot of rules. There's a lot of little exponent rules. You learn these in Algebra 1. You actually learn some of these rules, quite a few of them in Algebra 1. But they get harder in Algebra 2 because we work more with fractions and more with these roots, these radical boxes. So you actually have learned this particular rule before, but like I was saying, it gets harder because we work with fractions and radicals, those roots. So when you look at this problem, you see that they say 5. They have the same base. So you keep that base number. Okay, it's the same base, 5. So in the answer, you keep that 5. But we do something with the exponents, with those powers. So this is 5 to the 1/2 power times 5 to the 3/2 power. So what do you think we do with these fractions? It's a multiplying problem, but you actually don't multiply the fractions. You do something else to them. No. You take 1/2 plus 3/2. You add your exponents. So it's the same base, you keep the base, and you add your exponents. You actually learned that before, but it looks harder because this is an Algebra 2 problem. Like when you were in Algebra 1, you did stuff like x to the 3rd times x to the 5th. That's the same kind of problem as this. And what do? You add those up, it's x to the 8th. 5, 6, and 8. It's the same as this problem, but our problem's harder because it has fractions up there. But you still add them. It's still the same rule as you learned that in Algebra 1. It's the same rule from Algebra 1. You see, I added 3 and 5. So I have to add the 1/2 and the 3/2. So what do you get when you add 1/2 and 3/2? You get 2, yeah, because you get 4 halves. That's the same as 2. So you get the same as 5 squared, 5 to the 2nd. And that final answer then would be 25. 5 squared is 25. Okay, so then let's try one where it's like 3 on the top over 3 to the 1/4 power. This is another rule you've learned in the past, but it looks harder now because it's an Algebra 2 problem with fractions. You have actually learned this before. I can do an easier one, like an Algebra 1 type. Like in Algebra 1, you did like x to the 5th over x squared. You know what you're supposed to do this time with these exponents? Yeah, you're supposed to subtract them and you get x to the 3rd. So this one was add exponents, add these. This one subtract the exponents. That's the same as the one I'm giving you on my screen right here. It's the same, but I don't see a number up by this 3, so isn't that a 1 when you don't see a number up there? So you're going to keep the same base. They have the same base again, just like the last problem. So the big 3 stays the same, you keep it. But you subtract the exponents, 1 minus 1/4. You have to literally subtract those. So keep the base, subtract the exponents this time. So final answer for this one would be 3 to the 3/4 power. 1 minus 1/4 is 3/4. So this time I keep the base again, and I'll just write what we did. We subtracted the exponents. That's what we did. Kind of the directions in red. See, we kept the base, So see, we did not divide the 3's. Some people want to try to divide the 3's. You don't divide the 3's. It's a common base. You keep that base. Okay, let's try another one. Okay, let's try. Okay, so let's try 40x to the 2/3 over 8x to the 1/3. Okay, so another fraction one just for practice. The base is like in this one, the base was 5. In the second problem, the base was the 3 number. What's the base in this problem? Yeah, the x. So I'm trying to like explain to you like this problem I'm giving you this time is a little different because I put some numbers in front, but those numbers in front aren't the base. The numbers in front are called coefficients. So you have a 40 and an 8. Those numbers in front are called coefficients, 40 and 8. They're not raised to a power. You see that? They don't have any powers on them. So you can actually divide those. Those are called the coefficients. 40 and 8. You can actually divide those. So what's 40 divided by 8? 5, yep. Okay, so it's 5 if you divide those. Okay, now it's kind of like the one we just did up here. We have the x's. Those are the same base, so it's still going to say x. So you keep the base. You keep the x, but what do you do with these fractions? Yeah, you subtract those exponents. So what's 2/3 minus 1/3? Yeah, it's 1/3. So the answer is 5x to the 1/3. Yep, so you divide your coefficients, then you subtract the exponents. So when you do a problem, you guys, you're going to have to look at them and think like, oh, what do I do this time? Do I add my exponents, or is it a fraction? Do I subtract my exponents? Let's try... Okay, let's try one with like roots around it. Let's try one that has 80 in like a 4th root over 5, and that's in a 4th root. This is a little different kind. So they're not the same base in the inside. They're not the same number inside, but they're both in this 4th root. See that? They're both in a 4th radical box. So you can actually write the whole thing like a big 4th root around the whole thing, 80 divided by 5. So that's like the strategy you want to use on this one, that if they're each like single radicals, you can, and they're both 4th root though, it's actually like the whole thing is 4th root then, right? The whole thing is 4th root. Because if you can do that, then these numbers inside of here, they're not the same, but that's okay. But you can actually divide them now that we rewrote it this way. You can actually divide these. So rewrite the whole thing in a 4th root. Now actually divide 80 divided by 5. What's 80 divided by 5? Because then I can get it simple down into one number. Yeah, it's 16. 80 divided by 5, that's actually, divide that, it's 16. And now you can figure out on a calculator the 4th root of 16. There's 4 of something that goes into 16. A fourth root means there's 4 of a certain number that goes into 16. It's like 2 times 2 times 2 times 2 makes 16. 4 2's make 16. Yep. Yeah, these are tricky. There's a lot of different rules to go over. And all right, let's try another one. Let's say you had 12 that's inside a cubed root times, and then there's an 18 inside a cubed root. So, since both in a cubed root, you can literally put the entire thing in a cubed root. So, even though these numbers are not matching, that's okay, but you can literally, since they're both cubed root, you can do cubed root of 12 times 18. You can put it all together. That makes it easier. That'll make it an easier problem. You can put it together. So you can literally times 12 and 18 since they were both in a cubed root. You can times them together. So you just grab a calculator, figure out what 12 times 18 is. That'll get it into one number that we can figure out. Yeah, it's 216. And then you could figure out cubed root of 216. A cubed root means there's 3 of something that makes 216. You can hit 3 and then that cubed root box key. The other day, if you guys were gone, I know there's a handful that were gone. We worked a lot on how do you type these in the calculator. To do a cubed root, to type this in the calculator, you hit 3 first, then the second key and the up arrow, the power key. That gives you a cubed root. See, it says 3 and then there's some kind of box around it, and then 216. Yep, it's 6. If you just find the key on if you just have to find the right keys on your calculator to get it. So that one's 6. Okay, what if you get parentheses? I didn't do any parentheses ones yet. We've done adding, we've done subtracting exponents when you divide, we've put things together. Yeah. You can just put 6 for the final answer, yep. Okay, then let's try parentheses. We haven't done any of those yet. Yeah, Omar, do you have a question? Only if it's like solving an equation with x in it. It is, you, like, how do I want to say it? It was just a simplify one, so you don't have to. If it said, like, solve this equation, and like an equation with a variable in it, then you do the plus minus. Yeah, they don't do it all the time. I know, it's weird. Yeah, technically, he's saying, like, the answer for this is technically, like, plus or minus 2. Because, like, negative 2, 4 negative 2's make 16 also. But if it's just a simplified problem, they're just looking for, like, the positive answer. Yeah. Okay, parentheses, guys. What if you have parentheses around things? Like, what if we have 2 to the 3rd power over 5 to the 3rd power, and the whole thing's in a parentheses, and then out here it has negative 1/3 power. We didn't do parentheses yet. When it has parentheses, you have to multiply your exponents. That's like the key here. Like you see there's parentheses, so it makes like a power and then another power on the outside. When it's like that, you have to multiply the exponents. And you have to do it, there's another number inside, there's this 5 to the 3rd, we're going to have to like multiply those also. See, so the negative 1/3 power on the outside, you're going to have to times with both of those exponents on the inside. So you have to take, on the top, it was 2 to the 3rd. see, like, literally that little 3, you have to times it by -1/3. I'm trying to, like, write the little steps so you see, like, you're going to have to multiply that. Here, I'll try to focus it in. Okay, you're going to have to times that, guys. And same thing on the bottom. You have to take the 5. It was 5 to the 3rd power, but you're going to have to times it by that -1/3. Because it's in a group, and you have to do that to both things. I'm trying to put a dot for times. All right, guys, let's see what we get. What do you get if you do 3 times -1/3? What do you get if you times those things? You get 2 to the negative something. Yeah, it comes out to -1. And then at the bottom, too, you do the same thing. That's also going to be -1. Okay, now we have negative exponents. Can't have negative exponents in the final answer. So, now we have negative exponents. Now we have to deal with those. When you have negative exponents, you flip it. You have to get rid of a negative exponent, you do a reciprocal, it's called. It's called a reciprocal. A reciprocal is when you, like, flip things. Like, how do you make this so it's not going to be -1 power anymore? You have to put the 2 on the bottom. You literally flip it. It's a flip. So it's gonna, the 5 is gonna be on the top of the answer, so that makes it 5 to the 1st. And then you put the 2 at the bottom. So you flip it so it's not negative anymore. That's what makes it so it's not negative anymore. You flip it so it's 5/2. So it's 5 to the, just regular 1st power. It gets rid of the negatives when you flip it. So it's 5/2. The answer. That's a lot of steps on that one. Okay, we're almost done. I was just trying to go over different examples that you're going to see. And there's a lot of rules. Okay, another rule is something like this. 1/5 plus square root of 3. Okay, so in math problems, the final answer can't have square roots in the denominator. Not usually. So we do this thing called rationalize the denominator. It's to get rid of the square root that's in the bottom of the problem. The final answer is not supposed to have square roots in the bottom of a problem. So you do a thing called multiply by the conjugate. So you do a thing called multiply by the conjugate. What's a conjugate? Well, you just look at the bottom of the problem. It says 5 plus square root of 3. The conjugate of that is 5 minus square root of 3. That's a conjugate. It's like an opposite. You just flip it to minus. If it would have already been minus, I would have made it plus. That's the conjugate. 5 minus square root of 3 is the conjugate of 5 plus square root of 3. So you literally have to multiply this out. You have to distribute it all. You have to distribute. You're going to have to distribute it all out. So if I distribute the top, you get 1 times 5, that's 5. 1 times this minus square root of 3 is still minus square root of 3. So when you times by 1, you know, it's going to be the same. The bottom part's the hard part. We have to times all this out. You have to do 5 times 5. That's 25. Then you have to do 5 times this square root of 3 that's way over here. And this has a minus, so it's going to be minus 5 square root of 3. It's not 15. You can't do 5 times 3 and make it 15 because the 3's in a box and the 5's not. So it's just 5 square root of 3. You don't, some people ask if you could make it 15. You can't. It's just going to be 5 square root of 3 minus. And then you times the middle ones. This is called FOIL. First, outside. Now you times the inside. They call it FOIL to help you remember the 4 steps. Then inside is I for FOIL. And this one's plus 5 square root of 3. And then last, the last step is to take this square root of 3 times this minus square root of 3. And so it's going to be minus, one of them's minus. What's square root of 3 times square root of 3? Yeah, what's the square root of 9? 3. When you take a square root of 3 times the square root of 3, you just get 3. It gets, you know, because 3 times 3 is 9, square root of 9 is just 3. It gets rid of the square root. When you take a square root number times another the same square root number, the square root goes away. So then, you're almost done, promise, it's almost done. These 5 square root of 3s, see how one was plus and one was minus? They're going to cancel each other out. So the bottom of the problem gets a lot simpler because those cancel. And what's 25 minus 3? It's 22. That's the answer. The top we had already. We just had to figure out the bottom, that big mess. It got easier, but stuff cancels. So these are going to be on the worksheet too. There's 3 problems like this that you can practice. There's 3 of these. It's whenever you see like a square root thing in the bottom of your fraction, you have to do this conjugate thing. It's just an opposite. It's just like times by the opposite and distribute. Okay, what if they had you do something like 2 square root of 20 plus 3 square root of 5? What if you have an addition problem? See, it's adding. These radicals, this one says radical 20 and this one says radical 5. They call those radicals or square roots. Like this, these radicals, right now they don't match, right? Like whatever's in here, right now it doesn't match. So what do? So I'm looking at it, they don't match. If they don't match, you can't really add it up like this. If they don't match, you need to try to simplify one of them. Or both, but sometimes it's usually at least one of them. So what can we simplify? We can actually simplify this one. Because 20 is a big number that you can break down more. That's how I know I can simplify that one. Like 5, can you break down 5 much more? Just 1 times 5? You know, it's pretty much. So I know it just like grabs my attention like, oh, I see a big number at 20. I could break that down some more. So you want to simplify 20. 20 is like 4 times 5, right? 20 is the same as 4 times 5. Because you can't add it up as it is because right now they don't match. So I'm not messing with the second one, the 3 square root of 5, that's fine. But I see a big number in the box, so I know I can simplify that one down some. What's square root of 4, you guys? 2. So a 2 can come out. You can solve that. Square root of 4 is a 2. And this 2 is still there. So see, you can simplify it. The square root of 4 is a 2. You can pull the 2 out. So what do you do with the 2 that was already out there and now a new 2 that you're pulling out? Multiply them together, that's 4 square root of 5. Now it's easy. Now it's into 4 square root of 5. Now we're going to be able to add them up, because now they both say square root of 5. Now they match. Now they both say square root of 5. So now you can literally add them up. It's like this is like the base. Now they match. So now that they match, you don't do anything else with these square root of 5s. You just add the numbers in front. What's 4 plus 3? So the answer is 7 square root of 5. That's the answer. See, you got there's a lot of little things today. So if they don't match, you need to work on it, work on one of them and simplify one of them down. If they already match, you're fine, you can add them up. Okay? Like, look at this one. You don't have to write this one down, but you see how they already match, like this one right here, those match. They said like cubed root of 5, cubed root of 5. They already match, so I could just subtract that. It's 3 cubed root of 5. See? That one's easy. Like, that one's easy. You didn't have to do anything. If they don't match, though, you have to work on it and get one of them simplified down. All right, so I know that's a lot, but you guys can do it. It's just, you know, the beginning ones you do on the worksheet are like our first part of our notes, and then when you get farther down, that's when you're going to run into some of these at the end. So I tried to do the notes too, kind of the order you're going to see things on the worksheet. So the first ones on the worksheet are going to be things like this. If you have parentheses, you got to remember to multiply. But if the things are written like side by side, you just add them or subtract. All right, so I'll give you the worksheet. You guys can have the rest of the class to work on it. Yeah, this is a lot of little exponents. A lot of little rules in it. Yeah, a lot of rules in this stuff. All right, so it says, yeah. So like the first one on your worksheet, I see parentheses 7 squared and then parentheses 1/4. So it's a power inside and then a power right on the outside. So you have to multiply those those exponents. So it shouldn't be too bad. Just got to figure out what rule to do. And like the one below it, just to kind of go over it again. See, I got a fraction. Okay, they both have the same base, but it's in a fraction. So when it was a fraction, we subtracted the exponents on our notes. So it's just going to be like that. You're going to have to figure out, what am I doing here? Am I going to multiply? Am I going to add the exponents? Am I going to subtract them? You got to figure out what to do with those exponents. Yeah, so like the first one, you can multiply those exponents. But this one here, you're going to have to subtract the exponents. You know, you just think about what rule you have to do.